Hello there, you are on Vectali, and today we are going to solve four more problems from rotational dynamics. Today's problems look complex at first glance, but once you see the idea, they collapse into something ridiculously simple. Let's break them down in Vectali style. Question number one. Consider regular polygons with a number of sides n, which is 3, 4, 5, and it goes till infinite, as shown in the figure. The center of mass of all the polygons is at height h from the ground. They roll on a horizontal surface about the leading vertex without slipping and sliding as depicted. The maximum increase in height of locus of the center of mass for each polygon is delta. Then delta depends on n and h as. Okay, so we are just rotating this n-sided polygon. Okay, let it be some n-sided polygon. Let's first see the triangle case. In triangle case, what are we doing is, with respect to this leading vertex, we are just trying to rotate it. So what will happen at this particular instant? This will be the axis of rotation. This will completely go down. When this reaches this point, again this will, that is this point, will start to be the axis of rotation, and it repeats on a loop. Okay, so the center of mass goes from this to the point where it's like this. So center of mass goes till this point. Okay, at this point, that is when the triangle is like this achieves the maximum height. Okay, what is this maximum height? It is nothing but this distance, right? So this is the maximum height and this is the minimum height. H, let's say this is h dash. So what are they asking is delta, which is maximum increase. So h dash minus h is what they are asking. Simple, right? So how are we going to find it? If you see an n-sided polygon, let's suppose this is an n-sided polygon, and this is h and this is h dash. As it is a regular polygon, I'm saying that these two angles are equal because these distances are equal, and we know by a property in mathematics this forms an isosceles triangle, so these two angles are equal. Now we can directly relate between h dash h and theta by saying h dash into sine theta is nothing but h. Simple, right? So how are we going? But theta is something we assumed it. How are we going to find this particular theta? There comes this property: sum of interior angles of an n-sided polygon is pi into n minus 2. But how? Here comes the question, right? So let's dive into math. So this is a triangle, right? If we connect each and every vertex with the center of the n-sided regular polygon, we get n triangles, right? So sum of the angles of interior angles of each triangle is pi. So we have n triangles because of n sides, correct? So n pi is the total summation, including the outer angle as well as this angle, right? So we don't want this particular angles, right? So we are going to subtract it. How will we subtract it without knowing the exact value? But we know one property. This is completing a particular circle, right? A complete round. As it is, a polygon is a closed thing. So this completes 360 degrees. That is 2 pi. So I'm just subtracting 2 pi. So from this, I get n minus 2 into pi as the sum of interior angles of a regular polygon. So from the total summation, I just subtracted this, obtaining this particular formula. Now, as it is a regular polygon, this is also theta. Okay, each and every triangles are congruent. So this 2 theta is nothing but this divided by n. So I'm just dividing it by each vertex. So dividing it by n. So 2 theta is nothing but pi by n into n minus 2. So I get theta as pi by 2n into n minus 2. At last, I get pi by 2 minus pi by n. Now, as a relation that I have previously said, h by h dash is sine theta. So h dash is h by sine theta. So which is h by sine of pi by 2 minus pi by n. So I get h by cos pi by n. So delta h is h dash minus h is h into 1 by cos pi by n minus 1. So this is very much simple, right? The only thing you need is this particular formula. This is also basic when you do JEE math. But this question seems to be much complex, right? Yeah. The each and every question seems to be complex, but the procedures and steps and ideas behind it are very much simple. Okay, now let's verify this one more condition. When n is infinite, we get a circle, right? Yeah. When n is infinite, we get a circle. So when we get a circle, the distance doesn't change. So delta is supposed to be 0. Let's verify the formula when n is infinite. When n is infinite, pi by n becomes 0. So cos pi by n becomes 1. So 1 minus 1, 0. So delta becomes 0. So our formula is correct. So option B is the correct option. Question number 2. A rigid uniform bar AB of length L is slipping from its vertical position on a frictionless floor. At some instant of time, the angle made by the bar with the vertical is theta. Which of the following statements about the motion is or are correct? There are few questions based on this motion. First, let me explain this scenario. What happens is this rigid bar is placed in such a way, vertical manner. Okay, now this is in equilibrium. So slightly we are going to disturb it. So it will move in some kind of trajectory. So what happens here is, as they have mentioned, it is a frictionless floor. So no horizontal force is acting on this bar system. Correct? Okay. So the center of mass has no external force in horizontal direction. So it should only move in vertical direction because of the influence of gravity. Correct? So the midpoint of the bar where the center of mass lies will fall vertically downward. That's an correct statement. Okay. Now the trajectory of point A is parabola. Now how are we going to do it? Okay. So we need a parameter to define the coordinates of A. Right. So the point A. I'm just saying let x comma y be the coordinates of A. Okay. And x coordinate is nothing but, if this is the midpoint, always lies in the same vertical. This is L by 2, right? So the x coordinate is always minus L by 2 into sine theta. And what about the y coordinate? Y coordinate is nothing but, if this is theta, this is also supposed to be theta, and this is L by 2 into cos theta. This is also L by 2 into cos theta. So I get L cos theta. So this seems to be an ellipse, right? With this supposed to be A, this supposed to be B. So A forms an ellipse or a part of an ellipse. Okay, from here it goes till this point. So it's a part of or quadrant of an ellipse. So it's not a parabola. So B is wrong, A is correct. So instantaneous torque about the point in contact with the floor is proportional to sine theta. So how are we going to say it? Okay, the point with in contact with the floor is B. So instantaneous torque about B is, the only force is mg. So mg is at this point and the perpendicular distance is d. And d is nothing but L by 2 into sine theta. So it's proportional to L by sine theta, right? Because mg into L by 2 into sine theta is nothing but the torque with respect to the point B. So option C is also right. When the bar makes an angle theta with the vertical, the displacement of its midpoint from the initial position is proportional to 1 minus cos theta. So this again an easy part, because this is L by 2, right? And this point is the distance, this distance or the altitude of the center of mass from the ground is L by 2 into cos theta. Okay. And initially it's nothing but at a distance of L. So when the angle is theta, its distance is L by 2 into cos theta. Okay. And initially it's L. Okay. When the bar makes an angle theta with the vertical, the displacement of its midpoint is, the initially it's L by 2 as we are speaking about the midpoint. So the displacement, this is the displacement delta, and which is L by 2 into 1 minus cos theta. So option D is also correct. This is a very much easy question. Why am I explaining this particular question is, this trajectory of parabola, trajectory of a particular point in this rigid uniform bar is a different one. Okay. And I have to conclude this particular part that if there is no external force acting on the system, there will be no motion, or, or there will be no disturbance of motion in that particular direction. Okay. I'm trying to conclude that particular point in rotational dynamics. Question number 3. A thin uniform rod AB of mass 1 kg and length 1 meter is held horizontally with two small insects, each of mass m by 6 at center of rod. At time t equal to 0, rod is projected in vertical xy plane such that its initial velocity of projection of center is 10 meter per second at an angle 30 degrees with the horizontal. And the angular velocity of the rod is 8 rads per second in minus k cap direction. Immediately after the projection, both insects start moving on rod without slipping away from center in opposite direction with speed 1 by half meter per second with respect to the rod. Take acceleration due to gravity g as 10 meter per second square and answer the following question. The only question is angle through which the rod will rotate before the center of the rod comes to the same horizontal level as it was at the instant when rod was initially projected. So this seems to be a very big and complex question. Let's break it down. If you see, this particular rod is there and two insects are there initially at the center, and these two guys are moving along the rod with half meter per second square, sorry, half meter per second speed. Okay, the I cannot term it velocity because always the direction is changing because the rod is rotating. Okay, so with half meter per second speed, these two guys are going to the end. Okay, so I have 1 second. With 1 second, it can travel half meter. At the end of first second, this guy will be here and this guy will be here. Okay, fine. Okay, now what happens is this whole system is here, right? I'm just projecting this system with 10 meter per second velocity at 30-degree angle with x-axis, where xy plane is nothing but the vertical plane. Okay, so if I project it down, let me analyze this situation. The center of mass remains same. I'm just stating this because these two guys does not alter the center of mass because they are moving in opposite directions with equal speed. So the center of mass is always at this particular point. Also, the rod center of mass is also in this particular point. So the center of mass remains the same throughout the motion, right? So if you see as a system, this is completely an projectile motion, right? Let's consider the whole thing as a particular particle which is projecting with 10 meter per second velocity at 30-degree angle. Also, there is no torque in the system due to gravity because the torque due to these two things get cancelled because they are equal and opposite in direction. So I'm just stating it. It is projectile motion of the center of mass. You just think about this condition. Okay. So if it is a projectile motion of the center of mass, let's calculate the time of flight when the center reaches the same horizontal position. That is the time of flight, right? So the time of flight is 2 sine theta by g, which is 2 into 10 into sine theta. So theta is 30 degrees, so I get half. So I get 1 second. After 1 second, this guy comes here. That's it, right? Now, omega changes as I changes. Why I am telling this thing? Because if you see, initially the moment of inertia is only due to the rod because these two guys, the insects, are at the center. But when this two particles or two insects move in this direction, the moment of inertia increases, right? So, in order to conserve the angular momentum as there is no external torque, omega should decrease, right? Correct? So, we have to write an equation of omega with respect to time because this moment is this distance changes with respect to time as it is moving with a constant speed, right? So let's write the equation. By conservation of angular momentum, I can write initial angular momentum is equal to the momentum at any particular time. Okay, I'm just denoting x. What is x is this distance? I'm just denoting it with x. When this is x, this is also x. Correct? So ml square by 12, which is the moment of inertia of rod, into omega naught is nothing but twice of m by 6 into x square plus ml square by 12 into omega. This is due to the moment of inertia of these two insects. Okay, now I'm just writing it in simplified form. Omega is nothing but L square omega naught by 4x square plus L square. Okay, now x is v into t, right? Where v is the speed half. So it's x is t by 2. So if I substitute here, I get omega is L square omega naught by t square plus L square. Correct? Now, omega is nothing but d theta by dt. So d theta is nothing but omega d theta. So I want theta, which I can get by integrating omega d theta. Right? So if I write theta is nothing but integral of 0 to 1. Why? The time varies from 0 to 1. At t equal to 1 is what the final condition we want. So 0 to 1 L square omega naught by t square plus L square dt. So what I get is omega naught tan inverse t, because L is 1 and omega naught is 8. Omega naught 8 I will substitute it later. So 0 to 1 I get omega naught into pi by 4 tan inverse 1 minus tan inverse 0 we get 0. So omega naught into pi by 4, which I get 2 pi. So this is a very simple question. The only concept you have to remember is there is we can apply the conservation of angular momentum because there is no external torque in this system and the center of mass remains same. These simple check boxes, if you tick these boxes, the question becomes simple and you completely solve the question using the simple concepts. Conservation of angular momentum, simple, and the simple projectile motion. That's it. These two concepts are the only thing we used in order to solve this question. Question number 4. The apparatus in this diagram consists of a solid cylinder of radius 1 centimeter attached at the center to two discs of radius 2 centimeter. Okay. It is placed on a surface where it can roll but will not slip. A thread is wound around the central cylinder. When the thread is pulled at an angle theta is 90 degree to the horizontal, which is directly up, the apparatus rolls to the right. Fill the largest value of theta for which it will not roll to the right when pulling on the thread. So, what happens is, what people find difficulty in this question is, they won't get this question intuitively. So, initially at 90 degree, they are saying that this whole system rolls to the right. Okay. Where at some particular angle, it starts rolling to the left. Okay. We want that particular angle. Okay. That's the simple conclusion of what they are asking. But how? The question arises, right? So before writing these equations and free body diagram, one cannot understand it easily. So I'm just writing it. If t is here and this is theta, I'm just writing its components t sine theta and t cos theta. Okay. And there must be friction. Why am I saying this? Because without this friction, how can this whole system move to the right? There is no other force, right? Even if the t is at 90 degrees, there is no horizontal force which will make it to move to the right. The only friction force, right? So friction should be acting in this directions. Let's take this particular direction. Now let's write the force and torque equation. So what happens is the torque is created by this force and as well as friction. Okay, I'm just marking this mass as small m and this is also small m and this is capital M. Okay, fine. Now let's mark this radius as 2r and this radius as r. So what am I saying is the torque produced by these two forces are in opposite direction. So T into R minus F into 2R. Why am I saying this? Because I'm just considering that this alpha as positive. Okay, clockwise as positive in my convention. So I'm just telling this torque should be greater. So TR minus F into 2R is the moment of inertia of the system into alpha. And for the force, I'm just telling F minus T cos theta is nothing but M plus 2A into A. And also, actually, they didn't mention it, but most of the cases it should be no, they have mentioned it where it can roll but will not slip. So, alpha is nothing but A by R. In this case, it's 2R. So, let me write it aside. So, these two are the equations. Now, for the limiting condition, because till it moves to the right, alpha is positive. Correct? Correct. Now, if it moves to the left, alpha becomes negative. Correct? Yeah. Now, for the maximum angle, alpha should be 0, right? That's the limiting condition. So I'm just taking alpha as 0 So A is also 0. So I'm just equating these two things. F is equal to T cos theta and TR equal to F into 2R. So I'm just writing it. From this I get T is equal to 2F and F is equal to T cos theta. By direct comparison or taking the ratios, you can directly say cos theta is half. So theta is 60 degrees. This is very much simple question, right? Yeah. So this intuition you won't get much easily. You have to solve more number of questions like this. This question seems to be confusing. Once you write the free body diagram and few equations, that's simple, right? In rotation dynamics, we use simple equations like torque equation, force equation, conservation of energy, conservation of angular momentum, conservation of momentum, coefficient of restitution equation. All these things are tricks and methods to solve a particular problem. That's it. Thank you for watching this video. Stay tuned with Vectorly. Do comment your doubts and feedbacks.